So a reminder that for this lesson you need to be taking clear notes, show all your workings out, listen to the instructions and pause the video when you're told to, and ask for help if you need it. So in this lesson we're going to look at what's called the addition law for mutually exclusive events. These are events that happen separate to each other. So a while back we looked at the idea of flipping a coin, and we said that the probability of getting a head or getting a tail is 1. It's certain. You flip a coin, you will get one of these outcomes. Now look at that, where that word or is, and look what it means we have to do. Where do we get the 1 from in this? Well, we take the probability of a head, which is a half, and we end up adding it to the probability of a tail, which is a half, and the two halves add up to 1. So this leads us to the big learning point for this lesson. When you see the word or in probability and you're given different probabilities, that means you have to add the probabilities together. So that's the big learning point for this lesson. You see the word or, it means you add probabilities together. So let's look at an example here. I've got this bag here. It contains 6 red balls, 8 yellow balls, 4 green balls. 1's taken at random, and we can start off with questions A and B here as we did in previous lessons. So first of all we find our total number of balls, which in this case is 18. So the probability of our yellow is very simply 8 out of 18, and I haven't simplified it because the question hasn't required me to. Green, 4 out of 18. Okay, so those are those two separate events. Now for part C, yellow or green, well, I literally do what I've just been doing. Probability of my yellow or probability of green means I add them together. Now in this instance, everything's got nice common denominators, so I can straight away say that that adds up to 12 over 18. Here's another example. Again, let's look at the steps. Got my total number. If I'm asked to, I find separate probabilities. So in this case, the probability of volleyball is 1 out of 10 children. The probability of swimming is 4 out of 10 children. And then you've got the probability of volleyball or swimming, in which case I just add them together. Again, they're nice common denominators, so I can just add the numerators as per usual. Here's some for you to try. Pause the video, and when you're ready, press play to see the answers. And here are the answers. Press pause, and when you're ready to proceed, press play. So here's a slightly different example. This time we're not given amounts of stuff, we're given probabilities straight away. So I'm going to do part A. So we're told the probability of a red is 1 out of 8, and the probability of a pink is 1 out of 4. Now again, red or pink means we have to add them together. We've got one slight problem on this occasion. We haven't got common denominators. So that fractions knowledge about getting denominators the same comes into play. Now what I'm going to do is I'm going to double 1 over 4 and turn it into 2 out of 8. Okay, now I've got my common denominators. Now I can add my fractions together. So my red or pink probability is 3 out of 8. Pause the video now and attempt parts B, C and D. Press play when you're ready to proceed. Here are the answers for B, C and D. Press pause, mark your work and press play when you're ready to proceed. Here's something slightly different. This time we're being given some probabilities and we've got to work out some separate numbers. So in this particular question, I've got 30 balls and I've got some red, some blue and the rest are green and yellow. And you'll notice I don't know how many green or yellow I have. I only know the probability of getting a yellow. So let's write down what we do know. So probability of getting a red, 10 out of 30. Probability of getting a blue, 6 out of 30. The probability of getting a green or yellow, therefore, must be 14 out of 30, because I need 30 balls, I've already got 16 of them, so I must have 14 left. Now I know the probability of a yellow happens to be 1 out of 6. So, since everything's out of 30, I'm going to change that into an equivalent fraction out of 30, which means it's 5 out of 30. Now this is where life gets interesting. I know a green or yellow is 14 out of 30. Just yellow is 5 out of 30, so my probability for a green must be 9 out of 30, because 5 and 9 is 14. So that's part A of this question sorted. Press pause, and now you've got all the information to work out part C, B, C and D. Press play when you're ready to check your answers. And here are your answers.